Now, how do you interpret the ANOVA table of a two-way ANOVA? First of all, you can ignore the top two lines and the bottom two lines. What we're interested in is the interaction effect and the two main effects. And here, what is called error in the two-way ANOVA is the within mean squares. That's what we compare the other mean squares to. In the two ANOVA, you always want to start with the interaction effect because the interpretation of the main effect depends on the interaction effect. So in this case, for example, we have the gender of people interacting with the socioeconomic status. And here it's just two levels, high, low. So to get this f value, we divide 1 by 40. We get 0.031, and this is a non-significant f value. Then, for the main effect of the gender factor, we get a mean square of 80. 80 divided by 40 is about 2, 1.96, and this also is a non-significant f value. Then for the main effect B, the effect of socioeconomic status, we get a mean score of 178 divided by 40 is 4.361, and this is a significant effect because the probability of getting such an f value is smaller than 0.05. So the meaning of this is that there's no effect for gender, there is an effect of socioeconomic status, and there's no interaction between gender and socioeconomic status. In the two-way ANOVA, once we find that there is a significant effect in the ANOVA, we go to conduct post-hoc tests. Now, here for the sleep medicine example, we divided the total minutes that men took to fall asleep divided by the total number of men, which was an average of 16 minutes. For the females, we divided the total amount of numbers that the females had divided by 12 is 31 minutes. So you see, the females took about twice as long as the males to fall asleep. Now, since we only have two levels, we do not need to conduct a post-hoc test because there's only two groups, so we already know that females are significantly higher than males. If we look at the dose effect, we do the same thing. We take the average minutes per dose, 10 milligrams, 23 minutes, 40 milligrams, 17 minutes, and 70 milligrams, 31 minutes. Now here we can analyze where exactly we find significant differences. So we can again perform a Sheffey test or, for example, a least significant difference test, depending on how strict you want to be. Now, the two-way ANOVA, if the interaction is significant, it means that one effect of one factor depends on the levels of the second factor. We always want to start our interpretation with the interaction effect, because it influences the interpretation of the main effects. So here, for example, for this example, we found a main effect for gender, and then we also found a main effect for the dosage, but there was no interaction effect. So that means it doesn't matter if you're a woman or a man, the dosage makes a difference. So we can't recommend to have a specific dosage depending if you're a man or a woman. The other thing that helps to interpret ANOVAs, two-way ANOVAs, is when you create a graph. Here, a simplified example where we see the three levels of factor 1, then we create a graph with the two levels of factor B. Right? So once we see they go up. So we know that there is a meaningful effect of factor A, but we're not too sure if the difference between B1 and B2 is significant. So we have an A effect, but no B effect. A effect, but no B effect, and no interaction effect. Here we would have a significant effect of A, B, but still no interaction. However, this graph is not correct. We have to look at these numbers here. And here we see there's no A effect, no B effect, but we see an interaction. You can spot interaction by looking at the graphs. Often when the lines cross you have an interaction, or when they fan together like this, or if they fan out like this. So we can look at graphs to interpret the meaning. Then another topic is